So what we have here today is a copy of Sonic the Hedgehog that does absolutely nothing. And what's interesting with this is that I've tried to change the capacitors, I've tried to clean it, and nothing works. So what I was thinking I should do is to check the ROM chip and see what happens with it, well, what it does by dumping the ROM. So let's do that. So now I plugged the chip into the ROM programmer and try to read what data it outputs. And what we get is this kind of readable mess. I got right next to it, I got the ROM data as it should look. And it's a bit different. Got more information, you can read what the program is. And you can also see that part of the information is there. So if we look at the hex code and compare it, what I noticed is that in position 0 it says 00, let's just do a byte swap over here. So then we got the same position. Not position 0, position 1. It says FF00000000 all the way down, then 45, 43, 4F, 20, and so on. And position 1 from chip says FF, so that's all fine, but then it says 80, 80, 80, so on, until C5, C3, CF, AO, AO, CF. So what I eventually figured out was that the data line that should put out either an 8 or a 0 always puts out an 8. Hex code is made up with 4 bits, so it can take any numbers between 0 and 15 or 0 and F that it's presented with. And because one of the bits is always pulled high, it always outputs an 8, even though it shouldn't. And what I did was that I tried to locate the pin by shorting it to ground, and then I figured out that the correct pin was Q7, that's data line 7. And if I short it to ground, or VSS as it's represented on the chip, it's always pulled as a 0, so it don't output even though it should. But if I put a resistor, this is a 1K resistor, and we should put it in position 28, so 21, 22, 4, 5, 6, 7, 8, and 30, like that. And we switch back. If we do another read on this chip now, and then we do a byte swap because Sega cartridges read the ROM like backwards or in a different way. Then everything looks all right, and we still got FF on position 1 at the top, so it outputs what it should output. So what I will do now is to resolder the chip back into the cartridge circuit board, and then I will add the 1K resistor and we will give it a try. Alright, the ROM chip is back in the board, and I have added a 1K resistor between data line 7 and ground. And now let's just put it back into the case temporarily, into the console, and see what happens. It works. No problems at all. Everything works perfectly. So, a simple resistor fixed this problem. And I'm really happy because I have been trying to figure this thing out for like a month or something. And finally I figured something out and looked at the code or what the chip was outputting and found a pattern and could find a cause for the problem. And when we have a cause for the problem, we can fix it. Thank you for watching. Please subscribe and like this video, and I'll see you in the next one.